Tempe, a section of Wolli Creek, is a place which has taught me to read cities a bit differently. It lies on Bijigal country. Approaching Tempe has meant slowing down, paying attention to water, tide, soil, and story. When zoomed out, Wolli Creek seems like a small thread on the NSW coastline, but as you move closer, it becomes clear that it's actually part of a really complex system, feeding into the Cooks River. This is the moment that caught my attention. Wolli Creek meets the Cooks River at Tempe, and suddenly everything shifts. Freshwater, tide, sediment, and urban infrastructure, all colliding at one point. In our urban design studios, we usually break the city down into streets, blocks, and buildings, but here in Tempe, I feel like these tools were not enough, which is why I turned to the framework by Pierre Belanger, who argues that cities are not primarily shaped by the built form that we draw, but rather by hydrological, infrastructural, and ecological flows. To analyze Tempe properly, I'm using two lenses: Belanger, who treats urban form as the product of flows, and Hromek, who positions land, water, and sky as active layers of country. Belanger's first idea is that cities operate as metabolic landscapes. Urban form is not something that is just designed. It is shaped by flows of water, sediment, species, and energy, all moving through the site. The second idea is that infrastructure is never just hard engineering. It also includes wetlands, mangroves, soil systems, and riparian vegetation. The soft infrastructure that actually stabilizes, filters, and shapes edges. The third idea is that floodplains are not just leftover land, they're active infrastructure. Floodplains store water, buffer floods, and creates habitat corridors that cities rely on. At Tempe, the floodplain is doing constant work by absorbing the stormwater, shifting the sediment, feeding the habitat, and this work actually shapes urban form just as powerfully as planning controls. In Hromek's framework, country is a living system of land, water, sky, and ecologies. Seeing Tempe as living country helps me to foreground water, tide, and ecological processes, the exact flows that Belanger identifies. We shall now apply this framework onto my area of study in Tempe. When I overlay the 1% AP flood map, we can see how strongly water structures the site. The blue area marks the fast-flowing high-hazard zone, while the pink fringe shows the slower flood storage areas. These zones have existed long before subdivision, and they continue to dictate where the roads and the buildings can actually exist. When I overlay contours, we can see that Tempe has a shallow basin-like topography, and the railway is sitting on the highest ridge. This is Belanger's point exactly. Urban form is produced by fields and flows and not just by planned geometry. Once transport flows are mapped, the link to lot boundaries becomes clear. The rail line is sitting on the highest ground and the lot boundary shapes bend and distort around it, and it is irregular where they negotiate flood risk edges. When I overlay building heights, we can see that the tall buildings cluster near Wolli Creek Station, where the ground is engineered and elevated. As we move west, the height drops quickly because soil stability and flood risk are different here. So this is Belanger's second principle: hard infrastructure only functions because soft systems are either supporting it or limiting it. The hard infrastructure, that is the railway, the roads, stormwater pipes, and bridges, creates a rigid frame that fixes movement and access. And the same frame also fractures country. As you can see, the stormwater viaduct is cutting straight across the floodplain, interrupting the natural east-to-west movement of water, species, and people. When we switch to soft infrastructure, mangroves, salt marsh, open space, and the waterway, the ground is telling a different story. These layers sit entirely inside the floodplain, and their shape is defined by hydrology, not streets. This is where the Hromek framework becomes more important. These are the living parts of country performing different functions, like filtering water, absorbing tide, and hosting habitat, as Belanger describes. Once contours are added, the ecological pattern becomes more clear. Mangroves occupy the lowest elevation. Salt marsh is sitting just above that band on ground which is only occasionally inundated. Higher, flatter areas transition into open spaces, operating as the buffer between flood storage zones and developable land. With zoning added, planning's response to the ecological logic becomes visible. RE1 and RE2 dominates the flood extent zone because this land must remain open and permeable to hold and convey floodwater. Build form intensifies the moment the ground becomes more reliable, hence the cluster of R4 and mixed use around Wolli Creek Station. When contours overlay zoning, you can see the dense zone sits above the 3 to 4 meter contour where the ground is more stable, and below this line RE1 follows the floodplain because that land must stay open to hold and move water. The SP2 rail corridor sits on the higher ridge, forming a hard boundary to the floodplain. The contrast in activity becomes clear. The station area concentrates cafes and restaurants and movement on higher ground, while the floodplain holds lower and open uses shaped by water. These patterns are not accidental, they follow the logic of the ridge, the river, and the floodplain. Together, they show landscape is something that we work with, not engineer against.